Here's another example for 5, 3. This time we are saying solve over the interval from 0 to 2 pi, including 0, not including 2 pi. So if you're looking at this one here, we have 2 cosine squared of x plus 3 sine of x minus 3 equals 0. So one thing that should stand out is that we don't have the same trig function here. And in the last one, we moved the cosecant over and was able to factor, but here you're going to have to use identities. So you're going to have 2, remember cosine squared is 1 minus the sine squared, and then plus 3 sine of x minus 3 equals 0. And I need to pause my monitors here. Okay, so if we distribute in and combine like terms, we would get 2 minus 2 sine squared of x plus 3 sine of x minus 3 equals 0. So I'm going to combine like terms, and at the same time, I want to get rid of that negative. So I'm going to end up with 2 sine squared of x minus 3 sine of x. Remember, at the same time, I'm also multiplying through by a negative 1. And then the 2 plus a negative 3 is a negative 1, but I'm multiplying through by a negative, so that becomes a positive 1. So now I think I can factor this. So I'm going to get 2 sine of x and sine of x. I'm going to have a 1 and a 1. Okay, I'm going to have them both as negative for it to work out. So this one's going to give me sine of x equals 1/2. This is going to give me sine of x equals 1. Okay. So remember, for those of you who need this step, you're really doing x equals the sine inverse of 1/2, and this is x equals the sine inverse of 1. So this is saying what angle gives us a sine of 1/2, which angle gives us a sine of 1. And this time, we only want to go from 0 to 2 pi. So from 0 to 2 pi, where's the sine 1/2? I'm hoping you're going to tell me at pi over 6 and 5 pi over 6. Okay, and where is the sine 1 from 0 to 2 pi? I hope you're going to tell me pi over 2. So those are your answers there.